we want to look at question 2 of the higher questions at level C, and the point M56 lies on the circumference of a circle with the equation given, and we have to find the equation of the tangent at the point M. So we're told that M, the point 56, lies on the circle. Now pause the video if you want to have a go, but the first thing you want to think is, what's the centre of the circle? And if we copy out the equation, minus 4x minus 14y plus 43 equals 0. If we have a look at the formula sheet on the exam, now if you look at this form for the equation of a circle, we're told that the centre is minus g minus f. So what we want to do is find the values of g and f. So let's write this format out. X squared plus y squared plus 2gx plus 2xy, sorry, plus 2fy, not 2xy, plus 2fy plus c equals 0. So we have to compare the coefficients with the format given, and if we compare minus 4 and 2g, you get that g is minus 2, and so minus g is going to be 2 because we need minus g and minus f. Two f is minus 14, and yet again we get f is minus 7, and minus f is 7. The centre is minus g minus f, so the centre of the circle is the point 2, 7, and I'm going to call the centre, let's call it C. Let's write, call the centre C. So anytime we want to refer to this point, we call it C. So we have that, and what we now have to do is we have to find the gradient of the radius that goes from the centre to the point M. Let's do a sketch of this. I know it's not straight, but you can understand what's happening. So that is on the circumference. That's 5, 6. this is the point 27, which is the centre, and you're going to get something that maybe looks like this. Sorry, no, it doesn't. That. So something that looks like that you possibly get. And you want to first of all find this radius and the gradient of this radius. We'll call this point at the centre C and this point on the circumference M. So we want to find its gradient. And that's 6 minus 7, 5 minus 2 is minus 1/3. I understand I'm doing this quicker than I would if I was doing a National 5 video, because finding the gradient of a line is National 5 content and it will appear a bit too simple if I show you in detail how I do this. But just as a warning, if you're watching the rest of this series of the higher questions, I go into some of it in less detail and I do it at a quicker pace than I would at National 5. Now we have the tangent, and this is the tangent at the point M. You'll notice that this radius and the tangent are perpendicular by definition of a tangent. So the radius CM and the tangent are perpendicular, so the gradients must multiply to make -1. So M of the tangent multiplied by M of CM is -1. And that's the case for perpendicular lines. The exception is if one of the lines is purely horizontal and the other one is vertical. That's the only exception. Otherwise, this rule applies. Now this M with the tangent symbol, which is a upside down T, that's what we use to signify the gradient of a tangent. So that equal to -1 divided by the gradient of CM. So we divide by this. Cancelling out the negatives, you get 1 divided by 1/3, which is 3. And we say the tangent gradient is 3. And the last thing we have to do is we have to substitute the information into the equation of the straight line. We have a point on the line given as A, B, and we have the tangent gradient. Now the point you use is not the centre of the circle, it's the point which lies on the tangent, which is the point M. Having a sketch of the situation totally helps, and I recommend you do one in the exam. Your gradient is 3 and your point is 5, 6. So y minus b is 6, m is 3, and in the brackets is x minus 5. Rearranging this, we get 3x minus 15, and the final answer is 3x minus 9, and this is the final answer. This is the equation of the tangent to the circle at the point M. So tangent at M. This is a very common question, and it's a very easy 4 marks to get. The first mark, you just have to find the centre of the circle, and you just have to look at the equation on the formula list and compare that with the equation that you're given for the circle. You then have to rely on the fact that the gradients of 2 perpendicular lines, straight lines, multiply to make -1 unless one is horizontal and the other is vertical. And a lot of it is National 5 straight lines, but just in the context of tangents to circles. So it's not too bad a question. So I hope you found this useful, and best of luck with the studying. Thank you for watching.